Alright, so we're going to tackle this nasty problem that is number 46 of section 3.3. We're asked to find the limit of something with both sign on the top and bottom. So, how do we do that? Well, first step was the question asking for, just to basically apply the limit when equals 0. If you try direct substitution, nope, no luck. So there's two things you need to solve this problem. The first thing is that we were given a limit earlier in the textbook that basically says the limit as x goes to 0 of sine x over x is equal to 1. Now the interesting thing is that you can replace that x with some other variable. So for example, if we just let x equals pi times y, where pi times y is equal to x, it's still true. So this limit is also true, which is kind of neat. And of course, we could replace that x with any arbitrary variable. It could be a, it could be b, or it could be x itself again. And it would still be true. Here's a quick little proof. If you want to pause the video and look at it, go for it. Otherwise, I'm just going to skip to the next step. So now that we know that little thing, the first thing I'm going to do is I'm going to separate this limit into two parts. So there's our two parts. Basically what I've done is I've taken the top and moved into one limit. I've taken the bottom and I've moved into another limit. Now, if you focus on the first part of the limit, we'll just pretend the second part doesn't exist a little bit. Does it look like our identity? And the answer is not quite. So what is missing here? I put it in bold so it really stands out, but our limit has an x on the bottom, and our current first term does not have an x on the bottom. So the x is basically missing. Now the question is, how many times have you crossed off an x on the bottom and x on the top, just to sort of simplify a problem? So the interesting thing is the reason you can cross off an x on the top and bottom is it doesn't change the value of the expression. So what we could do is we could sort of reverse that process and just add an x on the top and the bottom as a sort of multiplication, and it won't change the value of the limit. So if we put that back into our question, you'll notice that now it's starting to look sort of like something that might be usable, but it'd be nice if we could get rid of that x on the top because it would look exactly like our identity. So how can we get rid of that x? Well, we're just going to move it over to the other side. Because it's a multiplication, you can also multiply the 1 on top on the other side by that x, and it removes it from our first expression. So now if you look at that left-hand side, it looks exactly like our identity. So that little 1 there with the arrow is indicating that I'm just going to replace that whole identity with a 1. So we're starting to get a bit closer to where we want to get to. Now the question is, can we direct substitute into that second limit? No, it gives you 0 over 0 and it's undefined. However, we're starting to get a little bit closer to what we want. If we just had a pi on the top, it would be almost identical to our limit. Okay, so we're getting closer here. Now our limit that we established earlier is this one here, and if you notice what's different, there's a pi on the top and it's also kind of flipped upside down, right? So we have to deal with those two issues. So let's see. If we could just get a pi on the top, it'd be great. So the way I'm basically going to think about this is if you imagine that you have a pizza and you cut it into 2 pieces or 4 pieces or 5 pieces, it doesn't really matter how many slices you cut it into, you still have one full pizza. So if we just pretend that we're a Ninja Turtle and we are going to cut that pizza into exactly 3.14 slices, you can basically replace that 1 with a pi over pi. Alright, now another rule we have is that we can move constants across a limit. And hey, what do you know? Do we know the value of this limit? And sort of. The problem is it's kind of flipped upside down when you compare it to our limit, right? So I'm going to pull out a boomer meme here, and we're going to perform a barrel roll. So all that we're going to do is we're basically going to flip the fraction by raising it to the power of -1. That's one of those math tricks you should throw in your bag that you can just pull out like bullshit on like garbage on a test. And yeah, so we'll just pretend we did that here. And hey, it works. And so now we know the limit here is 1 for that expression on the inside when you throw the 0 in, right? If you take 1 and you raise it to the power of -1, it's still 1. Anything multiplied by 1 doesn't change. So we can basically take the outside, multiply by 1, and we get 1 over pi. And so now we've applied the limit. There's nothing left to do here. We can just say this is our answer, that the limit as x approaches 0 of sine x over sine pi x is equal to 1. So we had to use quite a couple math tricks, and one of the math tricks is that you can basically multiply anything by 1 and turn it into a fraction if you need something on the top and bottom. And the second one is that you can flip a fraction if you raise it to the power of -1. So hopefully remember those tricks going forward. If you found these tricks helpful, try liking this video so more people can see it. And if there's a specific problem that you'd like me to solve, just go ahead and leave a comment down below, and I will try to solve that problem for you. And if it's not in this textbook, my email address is in the description. You can just email me a copy of the picture, and I'll see what I can do. Have a great day, guys. Bye.